Okay, so today we're going to be looking at the cosmic catalog again. We've looked at this with the absolute value function, and today we're going to be looking at the quadratic function. Okay, so the function family name is the quadratic. And the parent equation is y equals x squared. Okay, and the transformation equation, which we also call the vertex form, is y equals a. We've seen that a before. X minus h squared plus k. It looks very familiar. It looks very much like the absolute value equation. We also call that transformation equation vertex form. And the reason we call it vertex form is we can look at it and know that HK is the vertex of the parabola. Now, quadratics form parabolas, just like we did in the absolute value equation. We also have our axis of symmetry. Just like in the absolute value, the axis of symmetry is the vertical line that goes through the vertex. It's the vertical line x equals h. And be mindful that this is a minus h. Okay, we got that confused a little bit in the absolute value. And same thing, if a is greater than 1, we have a vertical stretch. If a is between 0 and 1, we have a vertical compress. We have vertical compression. If a is negative, less than 0. If a is negative, we have a reflection over the x-axis. Okay, which means your parabola opens downward. So let's look at the parabola. There are some very important points that the parabola goes through. I'm going to zoom in a little bit here so we can see it. Okay, your parent function, if I plug 0 in for x, y is 0. If I plug 1 in for x, y is 1. If I plug 2 in for x, y is 4. If I plug negative 1 in for x, negative 1 squared is 1. If I plug negative 2 in for x, it's also 4. So we have this symmetrical parabola, and these are curved. It's not like the absolute value. Okay, it curves. It's really hard to draw on the whiteboard. Okay, so it is a parabola. These are not linear. And these actually, it looks like it goes in a little bit, but they actually keep getting wider and wider forever. Okay, so let's look at some of the characteristics. What is the domain of this function? How far to the left does it go? Does it start? Because remember, you read from left to right. How far to the left does it start, and how far to the right does it go? Well, remember, I said these get wider forever and ever. So the domain is negative infinity to infinity. The range, however, is the lowest y value to the highest y value. So the lowest y value on the graph is 0, and 0 is part of my range, so I put a closed bracket. And the y's go up forever, so it's 0 to infinity. Okay, it's increasing. It's increasing right here. Here is where my function is going up. What x values are represented there? So when we look at where it's increasing, we're looking at these x values. So the x values that are represented there are 0 to infinity. And remember, I do not include the vertex in the intervals of increasing and decreasing, because at the vertex it's neither increasing nor decreasing. So where is it decreasing? You just heard my dog bark, sorry. Where is this decreasing? It's decreasing, if you read from left to right, it's decreasing here. So what x values from left to right are represented there? And those x values start, start at negative infinity and go to 0. And again, I do not include the vertex. Okay, I'm going to shrink us down here a little bit so we can see. And again, oops, put bracket there. Again, there are no asymptotes here. We're going to get to functions in chapter 4 that have asymptotes, but these do not have asymptotes yet. Here, my x-intercept is 0, 0, which means my y-intercept is 0, 0. Maximum and minimum values. These are y values, remember? Y values. So does this have a maximum y value? And the answer is no, it does not have a maximum y value because the y's go up forever. What is the minimum y value? That's 0. And remember, that should pertain to your range. Okay, your range is your possible y values. I'm saying my y values start at 0 and go to infinity. So my minimum y value is 0. One thing I didn't add to this, which I should, is two things: the vertex and the axis of symmetry. So the vertex is obviously 0, 0, and the axis of symmetry is the vertical line x equals 0. So let's look at that axis of symmetry. I'll try to use a different color highlighter here. The axis of symmetry is this vertical line that goes through the vertex. And so that vertical line is x equals 0. Okay, now let's transform this equation. Okay, it's still going to be a quadratic, but we're going to apply some transformation. So this is going to be very familiar to you guys, okay, from absolute values. So y equals negative 2 x minus 3 squared plus 1. So let's talk about these transformations. You know these transformations, okay? The minus 3, what does that do? It makes my graph go right 3 units. Okay, the plus 1 makes my graph go up 1 unit. The 2 makes a vertical stretch of 2. And the negative makes it reflect over the x-axis. Now, these are going to be very different in graphing than the absolute values because we cannot apply that trick I showed you with the slope. Okay, it's a little bit different. So, let's go ahead and look at our parent graph. So again, I'll zoom in a little bit so you can see the parent graph a little bit. The parent graph goes through 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. Okay, so I'm going to apply these transformations in order of PEMDAS. Now this is the way I did it in the video with absolute values, and we do have to do it the long way here because we can't use the trick with the slope. Okay, So let's just I guess my dogs decided to wrestle when I started recording. Let's talk about the vertex. So this I'm going to do right first. I'm going to do vertical stretch and reflect sort of together. And then I'm going to do it up one last. Okay, so vertex. I have to move the vertex right 3. 1, 2, 3. Okay, now to apply the stretch, I take the y coordinate. You could do the stretch and reflect at once. I take the now I take that number and I multiply it by -2. So I moved it right 3. Now this is the second step I'm doing. I'm going to multiply the y coordinate by -2. Well, the y coordinate is 0 times -2 is 0. And then I shift it up 1. So my vertex is right here. Okay, now let's take this point 1, 1. Again, we're going to do it in this order. We're going to shift it right 3, multiply it by -2, the y coordinate by -2, and shift it up 1. So here's 1, 1. I'm going to go 1, 2, 3. What's the y coordinate here? The y coordinate here is 1. If I multiply it by -2, it's now down here at -2. But then I have to shift it up 1, so it's right there. Point 1, -1, shift it right 3. 1, 2, 3. It's right here. The y coordinate is 1. I multiply it by -2, so that puts me -2, but then I have to shift it up 1. Okay, right here, the point 4, 2. 1, 2, 3 to the right. What's the y coordinate? The y coordinate is 4. If I multiply that by 2, it takes me down to -8. 1, 2, 3, 4, 6, 7, 8. But then I have to shift it up 1. And now you could probably start to use a little bit of symmetry since we know that this is the axis of symmetry. This point is 1, 2 to the right of the axis of symmetry. So let me draw that axis in so you can see it a little better. I'll draw it with a thin highlighter. The axis of symmetry on this new blue graph. I was going to do a thin highlighter, but I guess that's not so thin. The axis of symmetry on this new blue graph is right here. So it's that point's 1, 2 to the right. So this point's going to be 1, 2 to the left. So it's right there. So you can use a little bit of symmetry if you want to just graph one side of the parabola and use symmetry to get the other. You can do that too. So then, as you can see, my graph got reflected over and it got stretched vertically, which means it's compressed horizontally. Stretched vertically, compressed horizontally. Okay, let's see what this did to the characteristics. Again, this is getting wider forever and ever. Okay, this is getting wider. Oops, sorry. This is getting wider and this is getting wider. Not as fast as the other one. But so the domain is still negative infinity to infinity. Now let's talk about the range. The range goes low to high. So how low does the graph go? It goes negative infinity. How high does the graph go? 1. And I use a closed bracket because 1 is part of the range. There is a y value that is 1 on the graph. Okay, so now where is it increasing? When the graphs reflect over, the sides of increasing and decreasing change. Okay, so my graph is increasing here to there. So what are the y values to that vertex? The y values to that vertex, I'm sorry, the x values, I don't know what I'm saying. The x values are negative infinity all the way, and that vertex is at 3. all the way to 3, and you do not include the vertex. Okay, where is my graph decreasing? It's decreasing. I gotta get this smaller even. It's decreasing from here to here. What are the x values represented from here to here? They are 3 to infinity. And we never include the 3. Okay, so again, we have no asymptotes. What is our x-intercept? Where does this thing cross the x-axis? Now, this is where it gets really a little bit difficult. You can't tell from the graph, and you can't guess. The x-intercept is when y is 0. So this is going to take a little bit of algebra to do. So I think I have room at the bottom here. Oh, not much. Okay, I'll try to do it over here. So my equation is y equals negative 2x minus 3 squared plus 1. So to find the x-intercepts, I have to put 0 in for y, and I'm going to have to do a lot of algebra to solve this. So I'm going to start by subtracting 1 from both sides. So I have negative 1 equals negative 2 times x minus 3 squared. Don't FOIL this out. A lot of people try to FOIL this out, and you don't want to do that. Now divide both sides by negative 2. So I get 1/2 equals x minus 3 squared. Now I'm going to square root this side and square root this side. So this side becomes x minus 3. This becomes the square root of 1/2, which I have to rationalize. So let's look at that over here. Square root of 1/2 is equal to the square root of 1 over the square root of 2. You guys did this in geometry. And then you multiply top and bottom by square root of 2. So you multiply the numerators, it's square root of 2. You multiply the denominators, it's 2. So that is rationalized. Square root of 2 over 2 is the rationalization of the square root of 1/2. Now I simply have to add 3 to both sides. So I have one important step. I forgot. Plus or minus. Anytime you square root both sides of an equation, it's always plus or minus. So what I have is I have plus or minus the square root of 2 over 2 plus 3, because I'm adding 3 to both sides, equals x. And usually we'll put the 3 in front. It should look familiar to you, almost like the quadratic equation, because it is. Okay, so those are my x values. So my x-intercepts, and we're just going to leave it like that. That's the exact value of where it crosses the x-axis. You can get the decimal equivalent if you want, if you put it in the calculator. So my x-intercepts are 2 of them. It's positive, it's 3 plus the square root of 2 over 2, 0, and 3 minus the square root of 2 over 2, 0. Okay, and as you can see from the graph, we do have 2 x-intercepts. Okay, we've got something around right here and around right there, and that's what those values are. Okay, so now the y-intercept. Where does it cross the y-axis? Well, we don't see it on our graph yet the way we graphed it. The y-intercept is a little bit easier than the x-intercept. So we'll come down here. My equation is y equals negative 2 x minus 3 squared plus 1. It's a little bit easier to put in 0 for x, because when you're finding the y-intercept, you put 0 in for x. So this is negative 3 squared is 9 times negative 2 is negative 18 plus 1 is negative 17. So my y-intercept is 0. I put 0 in for x, negative 17. Okay, does this graph have a min or a max? It has max, right? Because it's turned upside down. It's got a maximum value, and that maximum y value is 1. Remember, it comes from the range. So it has a maximum of 1, and it's a max, not a min. Inflection point we'll talk about later, but this one doesn't have one. The vertex of this parabola is 3, 1. And I want to look at our equation and see exactly where we could get this from the equation. It's right here. Remember our vertex form was y equals a x minus h squared plus k. So h is the x coordinate of your vertex and k is the y coordinate. So be careful, the x coordinate isn't -3. Remember, a -3 shifts it to the right, so it becomes +3. And the axis of symmetry is x equals 3. It's the vertical line that goes through the graph. Okay, all right, for sake of time, I'm not going to do another transformation. We may do one in class. Okay, good luck with this.